Let's solve one previous question of function from set theory. This question was asked in GATE CS 2014 set 3 question number 2. Let x and y be finite sets and f x implies y be a function. Which one of the following statement is true? And 4 options are given. Let's analyze one by one option. Option A, for any subset A and B of x, f of A union B cardinality equals to f of A cardinality plus f of B cardinality. Let me take an example like x contain 1, 2, 3, y contain A, B, C, and f of 1 equals to B, f of 2 equals to A, f of 3 equals to C. It is both one to one and onto functions. Here it is just written function. So you can write any type of function. You can take one to one function or onto function or bijection function anyway. Let A equals to 1, 2, its subset of set X, B equals to 2, 3, which is subset of set X. Now option A, so f of A union B. F of A union B will be f of 1, 2, 3. A contain 1, 2, B contain 2, 3. So f of 1, 2, 3, that will be f of 1 is B, f of 2 is A, f of 3 is C. So it will be 3. Now f of A cardinality plus f of B cardinality. A contain 1, 2, f of 1 is B, f of 2 is A. Two elements, its cardinality is 2. F of B will be f of 2 is A and f of 3 is C. So it's again 2. 2 plus 2, it's 4. In LHS we got 3, in RHS we got 4. LHS is not equivalent to RHS. Actually, when we are finding cardinality, we should subtract the intersection, right? Here we are not subtracting intersection, so both are not equal. So f of A union B cardinality is not equivalent to f of A cardinality plus f of B cardinality. We should subtract the intersection. Next option B, for any subset A and B of X, f of A intersection B equals to f of A intersection f of B. Let me take same example. Now f of A intersection B. First A intersection B is 1, 2, intersection 2, 3, it's 2. Now f of A intersection B, so f of 2 equals to A. Now find f of A. A contains 1, 2, so f of 1 and 2, it will be B and A. Then f of B, B contains 2 and 3, so f of 2 and 3, f of 2 is A and f of 3 is C, so A and C. Now both intersection f of A intersection f of B, BA intersection AC, it will be A. So here we got same. For both LHS and RHS, f of A intersection B is equivalent to f of A intersection f of B according to this example. Let me take a different example and check whether both are same or not. Here we consider a one-to-one function. Here I am considering for f of 1 and f of 3 both A. Both maps to A and f of 2 maps to B. In question, it's not written about which type of function, it's just written function. So you can take any example. Now let me find f of A intersection B. F of A intersection B. A contain 1, 2, intersection 2, 3 and its function. So 1, 2, intersection 2, 3, it will be 2, f of 2. F of 2 is B. And RHS is f of A. F of A is what? F of 1, 2. F of 1 is A and f of 2 is B. So we got A, B. Now f of B. F of B, B contain 2, 3. So f of 2, 3. F of 2 contain B. F of 3 contain A. Now both intersection. So here AP, here BA, both intersection will be AB. and in LHS we simply got B. Is B equivalent to AB? No. So in this example, we found LHS is not equivalent to RHS. So option B is also false. Next, check option C. For any subset A and B of X, f of A intersection B cardinality equals to minimum of f of A cardinality and f of B cardinality. Here we are considering the main example. Now f of A intersection B cardinality. What is A intersection B? A contain 1, 2, B contain 2, 3. So A intersection B will be 2. Now f of 2. F of 2 contain A and its cardinality. So A cardinality it will be 1. LHS we found 1. Now RHS f of A. A contain 1, 2. So f of 1, 2. F of 1 is B and f of 2 is A. So it will be A, B, its cardinality it will be 2. And f of B, B contains 2, 3. F of 2, 3 it will be A and C, and we need to find its cardinality, it's 2. Now minimum of 2 and 2 it will be 2. So at LHS we found 1, RHS we found 2. Both are not same. So option C is also false. For any subset A and B of X, f of A intersection B cardinality is not equivalent to minimum of f of A cardinality and f of B cardinality. Next we will check option D. For any subset S and T of Y, f inverse S intersection T equals to f inverse S intersection f inverse T. So let me take two set S and T which are subset of set Y. Set Y contain A, B, C. So let S contain A, B, T contain B, C. Now F inverse S intersection T. So F inverse what S contain A, B, and what T contain B, C. We need to find intersection of both. So intersection of AB and BC, that's B. We need to find F inverse B. F inverse B equals to 1. Now RHS F inverse S. What is S? AB. So F inverse AB. What is F inverse A? F inverse A is 2 and F inverse B is 1. Now F inverse T, what T contains B, C. So F inverse B it's 1 and F inverse C it's 3. Now intersection of these two, 1, 2 intersection 1, 3, it will be 1. So here LHS is 1, RHS is also 1. So both are same. Hence we can say for any subset S and T of Y, F inverse S intersection T equals to F inverse S intersection F inverse T. Hence answer is option D. This type of question you need to solve by taking some example. I already discussed function, just go through the lecture, and if this lecture is helpful for you, please like, share and subscribe. Thank you.